Hi guys, I promised you a video today to help you understand a little bit better about hierarchy. So if you watched the video that I posted this morning of how to do the questions that are due this afternoon, you'd see that I used the example of animal, cat, and kitten. So this afternoon, I'm going to use a different example. We're going to say, use the example of plant, tree, and oak. So an oak tree is a very specific kind of tree. All oak trees are trees. All trees are plants. Are all plants trees? No. There are grasses, flowers, bushes, you name it. Are all trees oak trees? No. There could be palm trees, pine trees, Christmas trees, lots of different kinds of trees. So, when you're very specific, the items on this side share all the traits of the things above it. So, oak trees have all the qualities that trees have, and trees have all the qualities that plants have. So let's think. Plants, they use photosynthesis. I'm not even going to try to spell that out. They are green. They have a root or a bulb. Okay? Trees have all of those same qualities. But trees, what's different, specific about a tree? Trees are tall. Trees have bark. And trees have trunks. Okay, so those are three things about trees. All oak trees, all are tall, have bark, and have trunks. They also use photosynthesis. They're green, and they have roots. Okay, I don't know why this is not focusing. Okay. So oak trees have the same traits as trees, which have the same traits as plants. But plants do not all have the same traits as trees. Not all plants are tall, not all plants have bark, and not all plants have a trunk. Only trees. Oak trees are a kind of tree that lives in the United States, has annoying pollen, annoying to Miss Napolitano because she's allergic to it, and it gets all over your car, and it's gross. And what else do we know about oak trees? Oh, they have acorns. Okay, so do all trees have those same traits? No, only oak trees do. But all oak trees have the same traits that all trees share. Okay, if you want to look at it, instead of going across, we're going to go look at it in a hierarchy like this, which looks a little bit like a family tree, where you see sometimes it would have your grandparents at the top, and then it would have your parents and your uncle or aunt, and it would have the kids listed down here. Okay, so it starts with plants. That's very general. Plants, we divide it into a couple categories of grasses and trees. Now, do grasses and trees, are they alike? No. But they both are they do share the same traits as plants. Okay? So, they both would share the same traits as plants, but they're different because they're on a different level and they're on different little arms of the chart. You have trees. We have oak, and then we have a palm tree. They're both trees. They share the same traits as a tree because it's above it, but they are not the same because they're on different little arms of the hierarchy. Okay? So let's now take this example and look at it with shapes. Okay, so are we going to focus, please? Maybe I put my pen here. So we have a quadrilateral. Quadrilateral means 4 sides. Parallelogram, and then a square. Square is a very specific kind of parallelogram, and a parallelogram is a specific kind of quadrilateral, okay? All parallelograms are quadrilaterals and have the same traits. All squares are parallelograms and have the same traits of parallelograms and quadrilaterals, but not all parallelograms are squares. Not all quadrilaterals are parallelograms or squares. So you look at it like this, on this hierarchy, we see that quadrilateral is at the top, okay? There's actually other things that could be up here, like plane figure, but we're just focusing on quadrilaterals. Now, quadrilaterals could branch off into 2. They could be either a trapezoid or a parallelogram. Okay, a parallelogram means that both of the pairs of the sides are parallel with each other. Perpendicular, what was I thinking? Parallel. Okay? A parallelogram then can be either a rhombus or a rectangle. The difference is that a rectangle has 4 90-degree angles, okay? And its sides are not the same length. These 2 sides are the same length, and these 2 sides are the same length. But the sides that meet, this one and this one, are not the same. A rhombus has 4 sides that are the same length, but guess what? Its angles are not 90-degree angles. They're both parallelograms. They aren't the same, but they both have the same traits as a parallelogram, which means they both have both sets of their sides are parallel. And what's tricky with the parallelograms is that a square is both a rhombus and a rectangle. So square has the traits of the rhombus because all 4 sides are the same, right? They're all the same length. But it also has the traits of the rectangle because each of its angles are 90 degrees. So all squares are rectangles. All squares are rhombuses. You could even skip a line and go, all squares are parallelograms. All squares are quadrilaterals. But you can't go this way. Not all quadrilaterals are parallelograms. Not all rectangles are squares. Not all parallelograms are rhombuses. So you see, the things at the bottom share all the traits from the things above it that it's connected to by a line. The things on the top do not share all of the traits of the things that are below it.